All right, let's get into it. We're going to talk about a whole side of numbers that, let's be honest, sounds a little weird. People literally call them imaginary. But what if I told you these numbers aren't just real, but they actually describe a secret dimension, a hidden world of movement and rotation that our modern world absolutely depends on? And this quote right here, it just hits the nail on the head. Think about it for a second. All numbers are human inventions, right? They're just concepts we made up to make sense of the world. So that name, imaginary, it was kind of a historical accident. These numbers are just as real as the number 2 or pi, and we're about to see why they're so incredibly powerful. So where did this whole crazy idea even come from? Well, it all started with a problem, a really simple-looking equation that just slammed mathematicians into a brick wall. It was a puzzle that the numbers we use every day, the so-called real numbers, simply had no answer for. Take a look at this. Seems easy enough, doesn't it? To solve for x, your first move is to subtract 1 from both sides. That gives you x squared equals -1. And the next logical step is, of course, to take the square root of both sides. And that is where everything grinds to a halt. And here's that wall. I mean, just think about it. What number, when you multiply it by itself, gives you -1? A positive times a positive is positive. A negative times a negative is also positive. So with the numbers we all grew up with, this is just impossible. For centuries, this was a total dead end. So how did they get past us? How did they break through the wall? Well, the solution wasn't something they found. It was something they made. They decided that if the number they needed didn't exist, they'd just invent it. It was this totally elegant, creative leap of imagination. And here it is. Meet I, the imaginary unit. Its whole job, its entire definition is just this. I is the number that when you square it, you get -1. That's it. That's the whole rule. By creating this one new piece for the puzzle, that wall we kept hitting just crumbled. We now had a key to a whole new dimension of numbers. So, now that we have I in our toolbox, we can build something called a complex number. All it is a combination of a real part, A, and an imaginary part, BI. It's kind of like a hybrid number, living in two worlds at once. Just about any number you can possibly think of can be written in this form. Okay, so how do we actually do math with these new numbers? Is it super complicated? Well, the great news is it's actually incredibly familiar. As one source puts it perfectly, it's really just algebra with a twist. You already know how to do pretty much all of it. Just look at this side by side. Adding complex numbers is exactly like combining like terms in the algebra you already know. You just add the real parts together, and then you add the imaginary parts together. That's it. See? No new rules to learn. Now, for multiplication, you probably remember this method from school. FOIL. Firsts, outers, inners, lasts. You do the exact same thing here, treating I just like you'd treat x. You multiply the firsts, the outers, the inners, and the lasts. But here comes the twist. At the very end, whenever you see an I squared, you just swap it out for -1. That's it. That's the only new rule you have to remember. Okay, so we've handled the algebra. It's neat, but it doesn't really feel like magic yet, does it? But what if I told you these numbers aren't just for calculating things? What if they're a language? A language for describing movement? This, my friends, is where everything gets really, really cool. To see the magic happen, we need a stage. And that stage is called the Argand diagram, or the complex plane. So instead of your typical x and y axes, we have a real axis running side to side and an imaginary axis running up and down. Every single complex number has its own unique spot, its own address, right here on this plane. And on this plane, we can start to see these numbers not just as little dots, but as arrows or vectors shooting out from the center. Now, each number doesn't just have a value, it has a length, how long the arrow is, and a direction, the angle it's pointing. So remember how we added these numbers a minute ago? Well, this is what's actually happening. You take the first arrow, and from its tip, you just start the second arrow. The answer, the sum, is the new arrow that goes from the very beginning all the way to the final endpoint. In other words, addition is just a shift across the plane. It's a journey. And this leads us to the big question. If adding these numbers creates a simple shift, what in the world happens when you multiply them? You might guess it just makes the arrow longer or shorter, scaling it. But the real answer is so much more beautiful and totally unexpected. All right, let's just do one. Let's take this number right here, 2 plus 7i. You can see it on the graph. It's an arrow pointing up and to the right into that first quadrant. It has a certain length, and it's pointing at a certain angle. Now let's see what happens when we do some multiplication. We're going to multiply our number by our special unit, I. So we distribute the I, and we get 2i plus 7i squared. And because we know I squared is just -1, the whole thing simplifies down to -7 plus 2i. So the question is, where is this new number on our map? And here it is. This is the magic. Look, our new number, -7 plus 2i, it's the exact same arrow with the exact same length, but it's been rotated by a perfect 90 degrees, counterclockwise. Multiplying by I isn't scaling, it's a pure rotation. This is the secret dimension we were talking about. So this is the big aha moment. This is the huge takeaway. We've just uncovered the hidden geometry of these numbers. Adding them creates a shift, and multiplying them creates a spin. This isn't just about crunching numbers. It's a way to describe and control movement in 2 dimensions. Now you might be thinking, okay, that is a super cool trick, but I promise you, this is so much more than just a party trick. This deep connection between multiplication and rotation is one of the most powerful and fundamental ideas in all of science and engineering. I mean, this property is basically the engine behind our modern world. Electrical engineers use it every single day to understand the rotating currents in AC circuits. It's absolutely essential for the math of quantum mechanics. The signals that your phone and Wi-Fi use, they are processed and understood using complex numbers. And hey, even video game developers use a very similar system to make characters and cameras spin around on your screen. So we started with a simple equation that seemed totally impossible to solve, and we ended up discovering that numbers can literally spin. It just goes to show you how a creative little invention in math can unlock a deep and beautiful truth about how the universe actually works. And it really makes you wonder, if a number we once brushed off as imaginary can do all this, what other secrets are still out there just hiding in the math waiting for us to find them?